Good afternoon, this is Jacob Walter Kendrick, MET 314 Thermodynamics. Today we're going to be taking a look at the Stirling engine. It's an external combustion engine, or at least it's supposed to be. As you can see here, we have our propeller, which is attached to our crankshaft, which has the 90 degree, 90 degree, 90 degree, and then comes out the other side with a 45 degree, and then this is attached to our air exhaust, and then this bounces up and down with the rotations. And then down here we have our displacer, which is made of steel wool, and the idea is that it works off of a delta T, a temperature difference. So if I have candle here, and then I have this, which is at essentially at equilibrium with room temperature, the idea is that the heat will rise and then will heat up the displacer, which is a compact steel wool, and then that will make the thin piece of steel wire bounce up and down, which should rotate the crankshaft, or essentially turning heat energy into kinetic energy in an extremely inefficient way. The reason this engine currently right now is not working is primarily for three reasons. One, the crankshaft keeps coming out because of wear and tear. That hole has gotten so large that the crankshaft keeps coming out. That's not quite 90 degrees, and so the crankshaft keeps coming out. That's first of all. Second of all, the displacer is not quite right, because there's no air coming out of here. I can assure you that. I originally put epoxy, and then epoxy didn't work, and so then I Gorilla Glued it and clamped it for a half hour. So there's no air leaking out of here. The air is going here, and then this has a double balloon, and so that's quite sealed. But again, from wear and tear, from taking it off and on so much, messing around with the displacer, the spot where the two cans join, heat is escaping. So it's essentially like I would have to, either replace one of the two cans or like significantly reinforce the air loss there. And then also, I was supposed to have so between these two is supposed to be a string, but I just am right now using thin steel wire to connect to the steel wool displacer. And you're not supposed to do that for internal friction reasons, along with, the steel doesn't want to bounce up and down as much, so there's some internal resistance, again, friction with that. But my string wouldn't work because I have a natural twine string. I couldn't find fish line. So really, you would need an artificial string, you would need a better displacer, and reduce internal friction. But it does run manually. The propeller does run, but see, so the crankshaft's not the problem. And the balloon bounces up and down. Right. But when you light the candle, all it ends up doing is burning the bottom. So heat is being transferred, but it's essentially just heating up the aluminum can. It's not really, and to the extent that it is heating up the air inside of the bottom portion of this quote-unquote engine, and it is definitely because I touched the steel wool. The steel wool displacer is getting hot. And it is displacing air. It's just displacing air that all goes out here and there and a whole bunch of other places, because these aluminum cans are however many millimeters, however many microns they are thin. They're ridiculously thin. So just wear and tear of constructing this device has caused so much air come out, as well as the internal friction. So I can show you. All it does is burn the bottom. even if I were to get it going first. All it's going to do is burn the bottom. Yeah, so even if I get the crankshaft going, let's see, it just came apart. Yeah, yeah, ooh, that bottom gets hot. Yeah, see, it, ooh, that's hot, that's hot. It burns the bottom. That is hot. That is hot, by the way, just for all you folks at home, that is hot. Yeah, and the, it's a little warm. I bet the bottom of it, it's a little warm. I thought it'd be warmer. I mean, yeah, the steel wool does warm up, but mostly you're just burning the bottom. Like I said, because the displacer's not quite right, and because of the internal friction, and because even like an hour ago when before that piece broke, when this was more of a solid construction, it wasn't quite burning it that bad, but the displacer wasn't getting enough movement up and down in order to actually move the crankshaft. So for future, I would probably use something thicker than an aluminum can. I don't know, maybe like a steel can, 2 or 3 steel cans or something like that, so that it would be thicker, so that when you're messing around making the holes, things like that, maybe have it be, 2 cylinders instead of having to take cans and make them into cylinders to begin with. That might be helpful. And then, yeah, there's got to be a better way to connect the displacer up to the crankshaft, because I mean, there's just so much internal friction and there's so much air loss here. So a valiant attempt, but at present it does not work simply off of a temperature difference. But proof of concept, for sure, proof of concept. I've seen many videos of people successful. The crankshaft was designed correctly, and the propeller looks good. The displacer visually looks good. It just doesn't work because there's not enough movement all the way up to the crankshaft. This has been Jacob Walter Kendrick, MET 314, Thermodynamics, attempt at a Stirling engine. Thank you, Dr. Komuniski, for a great semester. See you all next semester.